In 2010, engineers confirmed what sunburned Las Vegas guests already knew. The Vdara Hotel's south-facing facade was a concave arc of glass, a parabolic mirror. It focused solar radiation onto the pool deck. Plastic lounge chairs melted, guests had their hair singed. The physics were simple, the simulation was never run. That incident is not an anomaly in architectural history. It is the expected output of any design process decoupled from physics. The current wave of generative artificial intelligence, diffusion models, text-to-image platforms, and their thin enterprise wrappers produces what this paper calls Escher paintings, geometrically arresting images that crumble under the interrogation of physical law. The discipline now faces a binary choice: generate digital art or engineer physical assets. Platforms such as Midjourney, Stable Diffusion, and DALL-E generate images by probabilistic pixel prediction. They learn what buildings look like from billions of photographs. They carry no internal model of what buildings must do. A generalist model has no knowledge of the Miami-Dade County Building Code. It has no awareness of shear forces from a Category 5 hurricane. It is not connected to the live inventory of regional structural steel suppliers. The result is the Escher effect: geometric paradoxes that appear plausible on screen and fail the first test of physical law. A column that looks structural may terminate midair. A glass facade that appears buildable may require custom materials at 20 times commodity price. The Veriprajna system reframes architectural generation from image production to decision production. A deep reinforcement learning agent operates on a discretized action space of engineering decisions. Place a column at grid intersection C4. Assign the W24 by 68 beam profile to member B1. Set slab thickness to 200 mm. These are not pixels. They are procurement items with known unit costs, known regional availability, and known structural consequences. 5 specialized agents run in a closed optimization loop. The generator proposes topology, a voxel-based material configuration within the buildable envelope. The physicist is a physics-informed neural network, or PIN. Rather than running a full finite element analysis, which can take hours, the PIN embeds the governing partial differential equations directly into its loss function. Equilibrium equations for structural loads. Navier-Stokes equations for wind pressure. Physics intuition at the speed of neural inference. The accountant prices every member against live material indices. The auditor checks every decision against SS 716 and the International Building Code. The optimizer, using proximal policy optimization, aggregates all inputs into a composite reward. That reward function is the paper's central claim. R total equals W1 times R physics plus W2 times R economics plus W3 times R constructibility minus the violation penalty. After millions of training episodes, the agent has internalized all 3 constraints. Gravity is non-negotiable, supply chains are rigid, budgets are finite. The cost of ignoring constraints is documented. When the architect Joern Utzon submitted the Sydney Opera House competition entry in the late 1950s, the concrete shells were geometrically indeterminate. They could not be built as drawn. A decade of engineering struggle followed to find the spherical solution that allowed precasting. The budget expanded from $7 million to $102 million, a 1,400% overrun. The building finished 10 years late. 2 physics failures follow the same pattern. The Vdara Hotel's concave glass facade focused solar radiation onto the pool deck. The remediation was inelegant: large umbrellas and non-reflective film on the glass. In London, 20 Fenchurch Street, the Walkie-Talkie focused sunlight onto the street below with enough intensity to melt the bodywork of a Jaguar parked at the curb. Neither failure required exotic analysis. A PIN with a ray tracing reward function would have detected the convergence zone in its first simulation pass and penalized the geometry. Constraint satisfaction replaces remediation. The paper's conclusion is direct. Don't generate art, generate assets. An asset is defined by its liquidity and standardization. An Escher painting has neither. The developer who accepts an AI-generated concept without physics validation is not receiving a design. They are receiving an invoice for future value engineering. The material cost differential makes this concrete: 50,000 square feet of glazing. A generalist AI specifies a curved surface, $25 million. The same area in standard flat glass, $1.25 million. The difference, $23.75 million, is not a cost overrun. It is the predictable output of any generative process without a cost constraint hard-coded into the reward function. Veriprajna, building true intelligence. Read the 14-page brief, approximately 21 minutes. The paper details the full reward function derivation, the PIN training protocol, the inventory constraint API, and the structural case studies on hurricane load optimization.